How are you guys?
Yeah.
Tired? All right, so back to counting. We kind of introduced a small glimpse at what a permutation was. Have y'all seen permutations and combinations? You saw that in what, Kyrie's class, honey? Okay. So as a reminder, a permutation is a way to write a factorial, but it's a little bit better way to write a factorial. So, for instance, if I were to say something like, how many ways can you rearrange the letters in the word dream? So if you think about this one little letter at a time, you would say, well, how many ways can I rearrange all 5 of those letters? Well, you have 5 options on your first pick, right? And you have 4 options on your second because you've already picked one. And you would just kind of go down until you ended up here, and that would be 5 factorial. But what if I said, all right, I want you to rearrange or make new words. When I say words, I put them in quotes to say that's very loose, like they don't have to mean anything. But how many new 3-letter, what if I said 3-letter combinations using those? Well, I could do that with, say, well, there's 5 options here. Then there's 4, then there's 3. Well, I can't write that 5 factorial because it would be too much, right? So another way to write both of these, including this one, is to use a permutation. And the one we looked at yesterday said NPN. But if you look a little bit further in the notes, it'll say NPR. All right. So when you're looking at this, and I think I have this in the notes pretty well, this will be like the number of things or items or letters or whatever, the number of things you're choosing from. You are choosing, or from which you are choosing. Okay? And then, you like that better? Okay. And then I don't want to end in a preposition. All right. And then R would be the number that you're actually choosing. Right? So the number that you actually are choosing. Okay? So this is like the total number that's available, and this is the number that you're actually picking from that group. So in this case, I could also write 5 factorial as, well, there are 5 letters to choose from, and I'm picking all 5. And 5P5 does end up giving me that because our rule is what? What's our rule for permutations that we talked about yesterday? That number is what? Is the factorial in the numerator, and then in the denominator, 5 minus 5, and we know that 0 factorial is the same thing as a 1. So again, I end up with 5 factorial. But in this case, I could say, well, there are 5 to choose from, but I'm actually choosing 3 of them, right? And when I choose 3 of them, what I'm really saying is 5 factorial over 5 minus 3 factorial. And what ends up happening is that 2 factorial, when you break up that 5 factorial, that 2 factorial cancels that 2 times 1.
How's that doing?
No, doing all right. From here on out, I got to get you to check in when you're late.
Huh?
From here on out, I got to get you to check in when you're late. All right. Are you with me on this? So I end up with 5, 4, 3. So you have a couple ways you can think about it. For a permutation, you can stick to your definition, which says n factorial over n minus r factorial. You're welcome to do that. Or you can also say, and I think about this all the time, it just makes it a little bit easier. I don't have to write it out and cancel stuff. It's the first 3 numbers in 5 factorial. Are you with me on this? So that makes me, like, what if I were to say, hey guys, there's 26 letters in the alphabet, right? There's 26 letters in the alphabet. And I said, how many 20-letter words can you make? And you're like, oh man, this is going to take forever. I got 20-letter words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I said, well, in the first letter, I got 26. And then after I pick again, I got 25, assuming we only used each letter once. And I'd have to go down this list, right? And it would be a lot to write out. But I could say, well, if there's 26 letters and I'm choosing, what did I say? 20. If I'm choosing 20 of them, I could just say 26P20 and call it a day. Because I don't need you guys to simplify your work. I'm not trying to get some big number at the end and go, oh. I mean, if you want to do that, you can. And your calculator has this button. You know, if you go look for it, I can go dig it up. I don't ever calculate these. I just leave it unsimplified, so I probably have to hunt for it a little bit. But I know if you go to the book button, the little book on your TI Inspire has a little textbook that looks like it opens up. If you click on the right side of that book, you've got an index, basically, like of every little every little application, every little button, whatever. It's stored like in a big, basically, table of contents, and you can click from 1 to 2 to 3 to 4, and you can find stuff if you don't know a quick way to get there. It probably is on just taking a peek right now. If I click on that book button, 2, 3. Yeah, I'd have to go hunt for it, but I know it's in there somewhere. 3. Lots of fun symbols under 3. No, don't see it. Under 2. Number, angle, list, matrix, vector, algebra. Probability. Factorial, number of permutations, number of combinations. So if you go to the book button and then the number 2 and scroll down a little bit, there's a probability, and you can scroll down. If you click on probability, you've got number of permutations, number of combinations, and it'll spit out NPR. And I believe the way you do this, let me just double check. That would be what, 65? I'll show you how to use your calculator in this regard. But again, you will not have to do this. Okay, so when you go to this button, again, if you go to your book button, you just click on the right side of your book. There's a little tab at the top. It's 1, 2, 3, 4, 5. Click on the number 2, and then scroll down to probability. Click on probability, and it opens up a little folder, okay? And you'll see factorials, number of permutations, number of combinations, and I'm sure there's a quicker way to get to it than this. I just have to go find it. You may already have found it.
You can just type it in, like NPR, and then.
Can you?
Yeah.
That works great too. If you do type in NPR,
And then.
do you have to use capital P?
Yeah.
Okay, you have to use capital P, and then you have to do parentheses. And when you actually, I'm going to try something else too. Again, you don't need to do this, so that's why I'm not. And you won't even have a calculator on this desk, but that's why I'm not familiar with this on this calculator. But if you do go to the book button and hit number of permutations, it says this. It'll say NPR parentheses. So it's a little bit more awkward than the 84, and you just type in 5, 3. Say you wanted to do that, and it'll spit out 60. But now that I'm seeing that, I wonder if 5, 2. No. So you can do, how do you do capital letters? I don't even know how to do that.
There's a shift button. It's next to the.
Oh, shift P.
You can also just type in like trig functions.
You can type in what?
Like trig functions, like cosine and sine.
Oh, right. So yeah, this seems like there'd be a better way to do this. Let me try one more thing. 5, shift P. This would be great if you could do this, but I don't know if you can. No. So yeah, you can type in N big PR parentheses 5, 3, which is a little awkward on the On the 84s, it's a little easier. You just hit 5, and then you hit your NPR button, and then you hit 3, and it spits out 60. The form's kind of bad here. But anyway, that is an option for you if you had your calculator and you just wanted to see without having to write out, because that's going to be a lot to write out, right? The first 20 numbers and 26 factorial, that would be a lot to do. And anyway, for whatever that's worth if you wanted to see. But on your test, you won't even have a calculator. You'll be just setting this up like this, calling it a day. Or you'll be writing out the first, if you actually didn't know what that was, you'd have to write out all 26 all the way through whatever you ended up getting, first 20 numbers in that. But we're just going to set it up. We're not going to do any simplifying. I'm going to assume that you can find this on your calculator and type it in. I'm really just more concerned with the mathematics behind it, that you understand that. All right, so make sure you understand this. And then the big key is the difference between a permutation and a combination is what idea? Because a lot of the other stuff is the same. How do you determine whether you use a permutation versus a combination? Anybody? Okay, so if you find yourself in a situation, and don't think this, like I have people all the time that say, well, playing poker and getting a hand in poker, the order matters because if you change the way you deal, I get a different hand. Like if I'm going, dealing the cards, whatever, and then all of a sudden I go the other way and deal the cards or vice versa, then that would give you a different hand, right? That's not what I'm talking about. What I'm talking about is when you're playing poker, you don't know anybody else's hand, right? So you're talking about the number of ways I could get 6 cards or whatever. So it's not talking about the order in which all the stuff was distributed. It's talking about in a particular situation, like my hand, what's the probability that I get blank? Or how many different ways can I get blank? So in the 7 cards that were dealt to you, did the order in which you received them have an effect on the outcome? Well, it depends on your game, but not typically in cards, right? If you are working in the media center, the librarian, and you're trying to get these books back on the shelf, right? So they remodeled the media center. They have all these books. They need to get them organized. Does the order in which you put them on those rolling carts have an effect on the outcome? Yes, because if you don't get them in the right order, nobody's ever going to find the book they're looking for. They've got to be in some kind of ordered system, Dewey Decimal, whatever they use these days. Are you seeing that? But anyway, you have to ask yourself that question. And there are going to be other questions you have to ask as well, but you definitely have to ask yourself that question. So, and again, I'm trying to run you through a bunch of these situations. There are going to be times when you can't count these really easily. It's going to be difficult for you. You're not going to be able to use nice, clean rules like permutations or combinations. Like you saw it yesterday in the thing where we had, okay, if there's a 1 through an 8 written on sheets of paper, how many ways can I get a sum of 12? Well, I can't use fancy combinations or permutations to get me anywhere counting those. I just have to think and write them out. So there are going to be times when it's all thinking. There's going to be times when it's just a form. There's going to be times when it's a hybrid of both. Heck, even how about the license plate problem? We did that yesterday, didn't we? So we did this with that license plate problem. I think it was something to the tune of, all right, the first number has to be a 1 because we're in Jefferson County. So there's one way to do that. And then I think I said we had 2 letters, right? And then we had 3 numbers, right? Those are numbers. And then we said we had 1 more letter, right? Now you could have said, rather than going, okay, I have 3 letters, and we said you can't have I, O, or Q, all right? So you can't have those. So we said that there's 23, and then once I use that letter, assuming that I can't use it again, it would be 23, 22, right? So if that's the case, I could have used a permutation. Now 23, 22 is pretty easy just to write that, right? But I could have said, well, there are 23 letters to choose from, and I'm picking how many of them? 2 of them. I could have said that, which is the first 2 numbers in that factorial. Or right here, the number options were 9, 8, 7, because I'd already used a 1, so there were 9 numbers left from 0 to 9. I could have said, well, I could have said 9, 8, 7 for the number of combinations that I could have there. Or you could have said, hey, there are 9 numbers to choose from. I'm picking 3 of them, which is the first 3 numbers in 9 factorial. And then I could have come back with the 21 here because I'd already used 23, 22. Or if you're really on your game, these really are 3 letters, right? So you could have said, I'm going to deal with these 2 and this one by saying 23P3 because I'm picking 3 letters from that alphabet. Now you can only use, and this is a big topic moving forward, you can only use permutations and combinations in situations where a factorial would occur. And factorials don't occur if I'm putting stuff back, do they? Think about it. If I can draw a letter, put it back in the mix and draw it again, you're not getting a factorial. You have 23, 23, 23, right? 10, 10, 10, because I'm allowed to reuse stuff. If I'm allowed to reuse stuff, we say that that choice that you make, and we talked about this yesterday, was independent, right? If it's independent of the next choice or the prior choice or whatever, if it does not have an effect on anything else around it, right? Like flipping a coin. I don't use up the heads, man. I'm fresh out of heads. It's got to be a tails this time. That never happens when you're flipping coins or rolling die. Those are called independent situations. I cannot use combinations of permutations or factorials on those. Are y'all seeing that? So you have to ask yourself the question, is it a combination or a permutation? If you have that option, but only when you have a situation where it's dependent, where something that you choose is going to affect the next outcome. And the choice there is going to affect the next outcome. And those are situations where you see the factorial kind of start showing up. 23, 22, 21, 9, 8, 7. And in those cases, then you're allowed to use combinations and permutations. And then you'd have to pick, well, which one is it? Does the order really make a difference? And if it does make a difference, use it. If it doesn't, you go with combination or some other way. So anyway, you're going to see a lot of this moving forward. But again, I just want to run through, just keep plugging through these problems. So did we get to the chairs problem, men and the women in the chairs? I don't think we did. So I'm going to probably hop around, skip stuff. But I just want to give you a taste of some of these things. And then we're going to do this today into tomorrow and then probably Friday, shift gears. And you probably have some questions. I hope you didn't go home tonight and try to do this whole packet. The key was under today's folder. You'll see counting principles, and there's a key in there with all that stuff. So you're welcome to look at that, but just kind of keep up with where you are, but don't feel like you got to get ahead. All right, so what about this? The problem says 3 men and 3 women. So you got 6 people, and they're going to be seated in a row with 6 chairs. Now, initially, you're like, sit where you want. But this problem says, find the number of ways that each situation can be arranged. So this problem right here is going to be a little bit of a hybrid, at least number 3, a little bit of hybrid of common sense. Well, actually, you could do it completely with permutations. A little bit, but I'm going to do it with a little hybrid of common sense, and then also with a little permutation mixed in. So check it out. You got these 6 chairs. Now, what are the conditions right here? The men and the women are to sit in alternate chairs. So one way you could do it is to say, oh, forget permutations, forget all that. I'm just going to use what's common sense. So how many choices do I have to sit right here? I got 6 people, right? It doesn't say that the man has to sit first or the woman has to sit first. It just has to say they alternate. So I could say, well, there's 6 options here. Although once I pick that option, what am I locking in that spot? The gender, right? So once somebody's in there, the gender has been chosen. If it's a man, then that means I have to have man there and man there, right? If it's a woman, I got to have woman there and woman there. So let's just assume, but I've accounted for both situations, right? Because it could be anybody. So if I pick that number right there, then how many options do I have for this next spot? 3. Why? Because I've already picked, say it's woman, right? So this has to be a man, but there are 3 men, right? You with me? And once I pick man right there, that would mean this has to be a woman. But I've already used a woman there, right? So what would this have to be? 2. And then if that's a woman, then this has to be a man, but I've already used a man. So this would have to be 2. And then this last woman is the last one left, right? And then this last man is the last one left. So I could have done this if I wanted to. Now, what I also could have done is said, let me ask you a question. There's 6 spots here. And this is really thinking advanced, but this is kind of where you need to go. Because at some point, I'm going to say there are 40 men and 60 women. And writing out 100 different spots and putting numbers in there is going to be very impractical. So I think this way. Okay, I've got to have in these spots right here, one certain gender, one of the genders. And then here, I've got to have one gender or the other gender, whatever. So in each of these situations, what am I really doing? I have 3 in that gender to choose from, and I'm choosing what? 2 of them, 1 of them, all 3 of them? To put in these spots, I have 3, say, women, and I'm choosing what? All 3 of them. So I'm going to say for this right here, I could say 3 to choosing all 3. And 3p3 is the first 3 numbers in the factorial. 3, 2, 1. And then right here, what do I have? The 3 in the other gender have to sit there, there, and there. So that's another 3p3. But right there, how many options did I have for this first space? I've already got the genders associated. But didn't I have 2 options for the gender? It could either have been man and woman. So that's 2, but I had to pick one of them, right? I can't put both in one spot. So initially, I had 2 genders to choose from, and I'm picking one of them. Now, if I do the math on this, I get 2 starting out. Basically, I'm saying, hey, there's 2 ways to do this problem, because 2p1 is 2. And then I'm saying, hey, 3 of those seats, 3p3. The other 3 seats, 3p3. But you know what happens if I do all the math of this? I get 2 times 3, 2, 1 times 3, 2, 1. And isn't that the same as this? But the advantage of this right here, thinking in terms of permutations, 2p1 or 2 times 3p3, 3p3, is when my numbers start getting really large and I get large quantities, I can still get this value without being really tedious in all the stuff that I do. See what you can do on 4 and 5. Look at, how about number 7? Okay, I got letters in the word equation. So there are, 8 letters? But I want to use 5 letter patterns can be formed, but Q is immediately followed by U, and I don't reuse letters. So using the letters from the word equation, how many 5-letter patterns can be formed in which Q is immediately followed by U, and I don't reuse letters? So I have to use Q and U. Are you seeing that? It said the Q and the U is in there. Now, so if Q is immediately followed by U, and I don't reuse any letters, and there are 5-letter patterns, help me out. What are my options, first of all? I got to use Q and U. You're not going to prison if you speak. Or if you're wrong. Somebody. Help a brother out.
Can you just start when you?
Okay, I could. So one of the options is to have a Q there, but if I start with a Q there, it immediately has to be followed by U. So definitely a QU could be in that space. Is that your only option?
Count Q and U as one letter.
Could. And you can't go UQ, right? It's got to be QU. So if you count that as one letter, you're really thinking about this as 4 things, right? Well, I'll get to that in a second. But I'm doing this kind of the methodical way this time, and then we'll get to that. Yeah, it says 5-letter patterns where Q is followed by U. I do hear what you're saying. I would word it something like, how many 5-letter patterns can be formed? And if there's a Q, it would have to be followed by U, but there doesn't have to be a Q. I would be a little bit more clear. But this says 5-letter patterns can be formed in which Q. So I'm kind of forcing your hand on the QU part. Is that the only place I could have Q and U?
You just see how many places like the pair Q and U could be, and that would be the number of words you could make, right?
Well, let's get started with that. So I could have QU here, QU there, and QU there. So there's 4 places I can have QU, right? But I haven't even started talking about the other 3 spots, right? I mean, clearly, having a QU up front doesn't mean I only have one way to spell that word, because I have all the other options for the other 3 things. But QU can go in here, there, or there, and that's 4 ways. So I'm going to start this with 4 ways. But once I pick that QU, what else is there to do? Like if I put a QU there, right, what is going on for the last 3 picks? Do what? Close. Why do I start with 6? Because I've taken out the Q and the U, right? So there's 6 letters left for this, then 5 letters, then 4 letters. So there's 4 ways to put the QU in there. It could be there. It could be there. It could be there. Or it could be there. But in each one of those, you had 6 letters left. 5, 4, 6, 5, 4, 6, 5, 4. So what I chose to say is there were 4 ways to place the QU, and then for the remaining 3 letters, 6, 5, 4. So one way you could write this is just like that. Another way you could write that is, well, rather than go 6, 5, 4, aren't I really saying for any remaining 3 letters, hey, there's 6 letters left to choose from, and how many am I choosing from those 6? Couldn't I have just said 6P3? And by the way, when you write 6P3, every year I have this this rogue permutation or combination guy that does this. 6P3. The P or the C is big. The numbers are small. Right? They're not the same size either. So you want these to be kind of like subscripts, 6P3. Not this, right? So try to do that. As long as I can understand it, I'm not counting stuff wrong, but it is a form issue. You don't have bad form with anything you're doing. So try to write like that. But that is another option. Now, if you think like Lily was thinking, she said, well, QU is stuck together. So it's almost like one option. And if you think about it as one option, like, hey, if I put the QU in there, it's going to go there, or it's going to go there, or it's going to go there, or it's going to go there. Couldn't I say, hey, there are 4 places to put the QU, but I'm only going to place it 1 time. So I could say when I'm placing the QU in there, there's 4 P1 places, which is 4, right? And then for the once I place it, that spot's out. For the remaining 3 spots, there are 6 letters to choose from, and I'm picking 3 of them. And again, if your brain's hurting a little bit, that's okay. I told you that yesterday. Your brain normally hurts in probability and counting as you're working through this, and then at some point you start getting more comfortable with it. It's like first couple days in the gym. You know, you're going to not be able to walk back from your leg workout or whatever, but you're going to be okay eventually. And remember, this is pre-cal. I'm not going to do some graduate level stuff. Most of the stuff, even if you can't see this, you'll be able to see this or some other way to do it, and it'll be tangible. I mean, I'm not going to, again, give you stuff that you can't actually write out, maybe once just to check your knowledge, but it won't be in a situation like this. All right, what about, I'm just jumping around. Look at number 11. Oh, no, actually, I like this one right here. Look at number 8. How many 5-digit numbers between and including 56,000 to 59,999 can be made if no digit is repeated? So I want 5-digit numbers. So how many options do I have on the first digit? It appears 1, right? According to this, it would have to be a 5. So 1 option there. How many options do I have on the second digit? 6, 7, 8, 9, right? How many options do I have on the third digit? If no digits repeated, I would have already used 2 of them, right? And they would have been different, right? Because that's going to be a 5, and this is going to be something 6 through 9. But it still leaves how many? 8. And once I write that 8, how many here? 7. And you can see that pattern starting to develop. But you know another way you could have done it? I could have said, okay, for this first digit, how many options do I have to choose from? How many am I choosing? One of those. I could have said 1P1. Now, why would I do that? I wouldn't. I would have just said 1 there, but I'm just showing you could. On the second choice, how many options do you have to choose from? 6, 7, 8, 9. How many are you picking? 1. That second option, you could have said 4P1. And then for the remaining 3, how many options do you have to choose from? 8. How many are you choosing? 3. I could have said 8P3. And again, is that going to save me time in this situation? Absolutely not. But if I said, hey, how many 100-digit numbers between blah, 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 that would have really been nice to be able to say, okay, there are 98 digits left, I'm picking 3, or there's 98 digits left, I'm picking 95 of them, whatever the situation, right? That would be a whole lot better than writing 98, 97, 96, 95, 94, and all the way down. Are y'all seeing this? But yeah, this would be kind of overly complicating it, but I'm just trying to, again, introduce these kinds of thinking to you. Tell you what, I'm going to leave that to you. I'm going to jump to distinguishable permutations. Now, what you've noticed, and this is kind of a math team question, I'm pretty sure most of you know this already, but I'll just remind you of it. When I was arranging words, letters like dream or cards or whatever, when I'm arranging letters like that, you'll notice that the words I was using all had the same, all had different letters in them. But if I ever have the same letter in them, like this particular one, Homewood Math Team, I've got 3 O's right there. I've got a couple M's in there. I've got some A's in there, a couple T's. I've got a lot of repeating stuff. And clearly, if I start rearranging letters, sometimes I don't get a new word, do I? Like if I just switch these 2 O's, or maybe this O with this O, or this M with this M, it's still going to spell the same thing. So even though it is a permutation, and a permutation says how many ways can I arrange them, it is a permutation, but it's not a unique one. And it's not a unique one because it looks the same. So if I ever ask you the question, how many unique arrangements or unique permutations or different words I can get out of this, the order still makes a difference. And I can still use I'll show you, I can still use a permutation, but I got to go back and account for the multiple letters that match. And the way I account for that is I basically divide out all the ways those letters could be repeated. And if you think about it, if there's 3 zeros, I could write, I'll use them, I'll call them 0, 1, 0, 2, 0, 3. If I write out all the combinations for that, it could be 1, 2, 3, 1, 3, 2. It could be 2, 1, 3. It could be 2, 3, 1. And rearrange the zeros, I'm not getting different words, am I? So I want to divide out those 6 ways. Well, the easiest way to do that is if there's 3 zeros, divide out a 3 factorial. So right here, there are 3 zeros. I'm dividing out a 3 factorial to not count those. There are 3 M's. I'm dividing out that. There are 2 E's. I'm dividing that out. There are 2 A's. I'm dividing that out. There are 2 T's. I'm dividing that out. Oh, 2 H's and 2 H's. I'm dividing that out. And then the number on the top, there are 16 letters. So I could have said 16 factorial, or I could have said there are 16 letters to choose from. I'm choosing all 16, because 16p16 means 16 factorial, right? And I use p because the order in which I arrange them obviously affects my outcome because I'm creating words. Are you with me on that? Okay. And again, I would only use a combination if, for instance, trying to think of a word I can do this with. Like Mason, right here. If Mason, if the number of letters was not a permutation, like clearly, if I say, no, Sam, come up here. Mason's probably not coming up to my desk to answer the question, right? Because that's not his name. But if it was a combination, he would, because it wouldn't matter the order. He would answer to anything. So so now, whatever, anything, he would respond to that, okay, if it was truly a combination. But he's not going to respond to that, right? These are different words. The order had an effect on the outcome. Saying those other things won't affect this. So that's why we're using a permutation when we count these things. So anything like that, this is a classic little math team question where they ask you this, and usually not too tough, right? You've seen those before, but that's the reason why we have to divide those out. So letters like words like monopoly. How many distinguishable combinations or different permutations or distinguishable ways or unique, quote, words can I make out of this? Well, there are 8 letters, so 8p8 or 8 factorial, but there's what? 3 O's. Now, you could also say there's 1 M, so I could divide by 1 factorial, and there's 1 N divided by 1 factorial, but that really doesn't matter because 1 factorial is 1. And when you're done with that, you can simplify it, but I don't need you to. How about this? How many different arrangements can be made with 10 pieces of silverware laid in a row? So I don't know, maybe it's maybe this is antique silverware and you're in some museum and you're laying out, you're trying to figure out a good way to organize this and try to figure out, and you're messing around with the arrangements. But 3 are, I should have said identical, but 3 are identical spoons. 4 are forks and 3 are knives. They're all identical in their unique category. So how many ways could I do that? And do you see that this is a lot like me arranging letters in the words? So if I have 3, 4, and 3, I've got 10 items, right? So there's 10 ways I can rearrange them if they were all different. But the fact that 3 of them are different, 4 of them are different, and 3 of them are different, I would have to go and divide by what? Try in whatever order. I'll let you mess with that too, 17. Combinations. All right, so combinations, the exact same mentality is going on with permutations, except it's a slightly different definition. And this time I'm going to use a combination when what? When the order that you receive them does not affect the outcome. And again, don't confuse that with, man, yeah, if I change the order in the deck, I get a different hand. So the order in the deck definitely affects the outcome. That's true, but that's not what I'm saying. I'm talking about the order in which you received whatever it is you're doing. If that order didn't matter, and sometimes it does matter. We talked about, I think about yesterday in that game of war, right? The order that the cards were dealt, because you're not really looking at them, or at least the order that are in your stack and you can't see them, that affects maybe how you win, right? You could be 1 less than the opponent each time and lose every hand. But if you just had a different card up front, you'd start getting ties and maybe win some. So certainly the order has an effect on the outcome in those. And but the difference in the definition is this. So in a definition with a combination, so again, what's important with permutations and combinations? You only use them in dependent situations, never in independent, never with replacement, never with flipping coins, never with rolling die, never with anything where one effect is not reduced by 1 on the next. If it continues to get reduced like a factorial, that's when you have a shot of using a combination or permutation. But combinations only when the order does not have an effect on the outcome. And if that's the case, the definition is very similar. So NCR, you're still going to start with n factorial on the top. You're still going to subtract n minus r on the bottom. That part is the permutation part right there. The only thing that changes is when you're finished, you go back and divide it by that r. So that's the thing that makes it a permutation. That makes it a combination. That part right there. So if you're dividing by an extra R, most likely your NCRs are going to be smaller than your NPRs. Sometimes they're the same, but most of the time they're a little smaller because you're dividing by an extra number. So the number of combinations is totally going to be smaller than the number of permutations for almost every given number, with exceptions like 0 or 1, because a 0 factorial or 1 factorial is 1, so it's not going to be anything different. All right? So, for example, got a card game going on right now, and I deal somebody 5 cards. You pick up the 5 cards. Obviously, the 5 cards that you get in your hand, the order in which you receive them does not affect the outcome, right? So the question here is the number of combination that these can be. So right here, I'm saying if you had ace, king, queen, jack, 10, or queen, ace, jack, 10, king, it's basically the same 5 cards. So if the order does not have an effect on the outcome, if I have these 5 cards, first of all, you're giddy if you get these 5 cards because it's an unbeatable hand. But if you have these 5 cards in poker, you'd say, how many different combinations can I receive these 5? Well, there's only one way to receive these 5, if the order doesn't matter. Now, if the order mattered, it'd be 5P5, right? If you got a jack on the first hand, you're like, jack, man. There's tons of hands that can beat this jack. I got it. The jack's my highest card. I have to play. That's not how you play poker. So you get these cards. You can arrange them any way. It doesn't really matter. You have 5 cards to choose from. These 5, you're picking all 5. And if you do the math on that, 5 factorial on the top, subtract it on the bottom, carry that one also over to the bottom. You can see those cancel. 0 factorial is 1, and you get a 1. So there's one way to receive a 5-card hand if the order doesn't matter. Now, if the order matters, 5P5's much bigger number, right? 1, 2, 3 is what? 6, 24, 120, maybe, something like that. So there's lots of different ways to arrange them if the order matters. Oh, yeah, you can see that right here. Okay, now what if I have 10 things to choose from and you're picking 3 of them and the order does not affect the outcome? So pretend you had a card game or whatever and you had actually 10 cards instead of 52, or instead of limiting you to 5 or whatever. If you have 10, again, you have to ask yourself the question, does the order in which I receive them have an effect on the outcome? And if the answer is no, then you got to ask yourself, is it dependent? Is me taking that first choice going to affect the next choice? And if you're not putting it back, or it's not something like flipping a coin or rolling a die that the options are always available, then if it's dependent and if it's the order does not affect the outcome, you can use a combination and really simplify the process. So 10 things to choose from. You actually pick 3 of those 10, 10C3. And you could leave it like this on the test. Although I will say on the test, there's one thing I'm going to actually have you crunch the numbers, and that's this. I'll give you something like 10C3 to see if you know the definition. Okay, and you would just go 10 factorial on the top, 10 minus 3 is 7 factorial on the bottom, and then an additional 3 on the bottom. So I normally don't even write this. I'm just going 10 on the top, the difference on the bottom, the other number on the bottom. And then I can see that 7 down to 1 is going to cancel with that, leaving me at 1098 over 32. And at that point, it shouldn't be hard to cancel stuff and get your 120. But I will only ask you that about a combination and a permutation. It'll be 4 points on your test, 2 points each. And then I'll walk away. And from here, after that, all you got to do is set these things up. All right, so check out number 18. All right, so state whether each arrangement represents a combination or a permutation. And then once you decide that, actually, you don't even have to, that's all you have to do. So tell me, and there might be more than one answer. Depends on your perspective. And I really pick good test questions where we've discussed all this ahead of time so there won't be surprises. But you could probably argue either way here. Students seating in a row. So let's just say I had a row of 10 chairs, or a row of 19 chairs, right? In the auditorium, and you guys, I say, hey guys, we're in row M, go in there and sit down. Does the order in which you sit have an effect on the outcome? Now, for you guys, I would argue no, because you're civilized, you're kind to each other, you get along, you know how to act. But man, if I had elementary school kids, do I want these 2 guys sitting next to each other? That could totally affect the outcome, right? So I might go take somebody nice and peaceful and put them in the middle, right? So you might say, well, the order does have an effect on the outcome sometimes. So in this case, you could probably argue both. But in the case I presented for you guys going and sitting in row M, I would argue that the order does not have an effect on the outcome. And if the order does not have an effect on the outcome, I have, say there's 19 of you. I have 19 to choose from. How many would you pick? All 19 of you? And I would say 19, C19, which ends up being 1. And I honestly do not care where you sit if I were to say that. If I say go to the auditorium, we're in row M, truly in my head, as long as you guys get there, I'm good. Are you seeing that? Yes, no? Okay, so I would argue combination there. But again, I don't give questions on the test where there's an argument. All right, what about answers on a true-false test? Oh, yeah, like I don't take the test and go, oh, there were 3 trues and 7 falses. Let's just have a little fun and scramble up my letters. We don't do that, right? The order in which you put those answers down definitely affected your outcome, didn't it? Definitely a permutation. What about this? A committee of 4 men and 5 women chosen from 8 men and 7 women. Combination or permutation? I would argue a combination. Because like if I'm right here and I say, hey guys, I need 4 guys to own my car. Can I get you, and you? Does it matter the order that I picked you? No, it would be like 19, choose 4. 19, C4, because the order didn't matter. Now, if I had said, hey guys, I need 4 people to serve as cabinet members for the SGA. And whoever I pick first is president, second's vice president, third's treasurer, fourth is whatever. And I go 1, 2, 3, 4. Now the order that I chose you had an effect on the outcome, right? So there's 19 to choose from. I picked 4, but the 4 mattered. The order mattered, had an effect, 19P4. But this just as a committee, you know, committees, it doesn't matter what order you picked. You're on the committee, right? Combination. Subsets of a given set. You don't even know what that means. You're a set of people. The females are a subset. The males are a subset. The blonde-haired people are a subset. Curly-headed people are a subset. The null set, nothing is a subset. You with me? So a subset, the males of a given set, would the order matter? No, it's just dudes in a group, right? Or ladies in a group. That subsets would not matter. That'd be a combination. A team chosen from a group of 12 people. I'd say a combination. Hey, I need 5 guys to play kickball with me. Oh, 1, 2, 3, 4, 5. What if I said this? A lineup, a baseball lineup chosen. You got 18 guys on a baseball team. I need to pick 9 to play. Picking the 9 to start could maybe arguably be a permutation, but picking the lineup in the baseball definitely has effect on the outcome, right? I don't want to put my 6'4", 275-pound slowest dude at the leadoff spot, right? And I certainly don't want to put my 5'7", 100-pound guy in the cleanup hole to drive in runs. Hey, see what you can do, guys. See if you can get to through this 25. Maybe even, yeah, at least through 25.
Hey, Lily, what's up? What's going on? Oh my God. Were they raisins?
Check one, go.